Welcome to today's Oracle Machine Learning Office Hours feature highlight. Our topic today is learn how to store R and Python objects in Oracle Autonomous Database with Oracle Machine Learning Datastores. Our speaker is Akash Dharamshi. I'm your host, Mark Hornick, joined by Sherry LaMonica. In this session, we dive into the datastore feature of OML4R and OML4Py, whether on Autonomous Database or Oracle Database, using the R, Python, and SQL interfaces. Akash will provide an overview of the datastore feature and then demonstrate using the various datastore-related functions and views using OML notebooks. As always, if you have questions, please post them in the Q&A and we'll address them during the session or at the end. Before we get started, let's hear from you regarding your level of familiarity with the OML Datastore functionality. Would you say, I've used OML Datastores in R or Python production solutions. I've experimented with datastores for a proof of concept, or I've run the sample notebooks. I'm familiar with what a datastore is, but have never used datastores. Or I'm interested to find out what this feature is all about. So we have the poll going. And I think we have folks who are certainly in the majority are interested to find out what this feature is about 70%. We have about 14% familiar with what it is and about 17% who have experimented with it in a proof of concept or run the sample notebooks. So with that, thank you for your feedback, and I will turn it over to Akash. Take it away, Akash.
So hello, everybody, and welcome to this Oracle Machine Learning Office Hours session. My name is Akash Dharamshi, and I am supporting the Oracle Machine Learning team. Today, we will be covering the Oracle Machine Learning Datastore as mentioned by Mark and its purpose in saving R and Python objects for use across database sessions and for passing in objects in embedded R and Python execution functions, all as part of the Oracle Machine Learning functionality. Thank you for joining us today. So let's start with a quick agenda for today's session. First, we will briefly review Oracle Machine Learning as a whole, and then explain the datastore capabilities. Next, we will go into some examples, and then cover the APIs and functions that are associated with the Oracle Machine Learning Datastore. Lastly, we will open up the notebooks environment to demonstrate and walk through a few examples. So let's begin with that overview of Oracle Machine Learning as a whole before we dive into the data store. So with Oracle Machine Learning, the Oracle database works as the high-performance compute environment to support invoking functions from the R, Python, and SQL interfaces. Oracle Machine Learning supports parallelized and distributed processing of machine learning algorithms and can leverage components such as the data store or the script repository to save user-defined functions, as well as native R or Python objects, proxy objects, and machine learning models in the database. Finally, users can invoke those user-defined functions using the SQL and REST APIs to integrate those results with applications and dashboards. So now let's move forward into the Oracle Machine Learning Datastore. So R and Python objects, including proxy objects, exist only for the duration of the current session unless explicitly saved. The Oracle Machine Learning Datastore enables users to save R or Python objects, including Oracle Machine Learning proxy objects, to a named data store, and then load those objects in later R or Python sessions, including for use in embedded execution sessions. The Oracle Machine Learning Datastore enables users to save and manage R or Python objects, including proxy objects, in the user's database schema to persist in the database until deleted, load R or Python objects, including proxy objects, for use across database sessions or use in named functions. Users can grant or revoke read access to data store contents to other database users, as well as use the data store to pass in arguments for use in embedded execution sessions. So let's cover some quick use cases while interacting with the Oracle Machine Learning data store. Some use cases include passing arguments to named user-defined functions with embedded execution, preserving OML4R or OML4Py proxy objects across R and Python sessions to keep from being dropped. Users can leverage the security provided by the Oracle database when managing objects. Users can load saved objects from a data store in subsequent sessions to be used in local named functions. Users can delete objects from within a data store or delete the data store entirely. And users can grant and revoke read privilege permissions to other users and to other users to a data store. So now that we walk through some quick use cases, let's demonstrate how the data store would be utilized during embedded execution. So we have two functions. The first function, build LM1, builds a linear model using the input data parameter, then saves the resulting model into the data store named with the second parameter, DS name, then returns that model. We will save that function to the script repository to be used in embedded execution. The second function on the bottom right, score LM1, scores the data labeled with parameter dat using the model loaded from the specified data store using the DS name parameter again. We will save this function as well in the script repository for use in embedded execution on the next slide. Now that our functions are saved into the script repository, we can invoke them from the SQL API using embedded execution. The first paragraph invokes build LM1 through the RQ table eval2 function, passing in DS name ds underscore SQL underscore 1 as the parameter. The build LM1 function creates a linear model using the iris data table and then saves the model to ds SQL 1. Next, we can access that model saved in the data store to conduct scoring by invoking the score LM1 function and passing in the name ds SQL 1 for the data store. We will invoke the RQ row eval2, passing in the function score LM1. Score LM1 will load the model that is saved into ds SQL 1 that was just conducted by the RQ table eval function, and then score 50 rows per invocation. So this example can start to represent saving objects to the data store within use for embedded execution functions. So I will pass it back to Mark for our second poll.
All right, thanks, Akash. So the question we have here is, which aspect of data stores do you find most compelling? Is it this ability to pass non-scalar arguments to embedded execution? User-defined functions? Is it to preserve native R Python objects and OML4R, OML4Py proxy objects across sessions? Perhaps to leverage database security to manage R or Python objects and avoid flat files, or to grant or revoke read permission on a data store to other users. So looks like we've got a really high percentage here of 85% saying preserve native R and Python objects and OML4R and Python proxy objects. In other cases, we've got about a third for leveraging database security to manage our Python objects, and another third for pass non-scalar objects, such as third-party models, to embedded execution. And a few are saying that grant or revoke read permission on the database to other users. So that's about a quarter of those. All right, well, thank you very much for that feedback. Back to you, Akash.
So now that we've covered some use cases and some basic examples, let's just walk through the list of functions that exist for managing data store objects. The ore.save or the oml.ds save in the Python interface. And just as a preface, we'll be covering the R interface as well as the Python interface. And so the ore.save and the oml.ds.save functions save R and Python objects to a named data store in the user's database schema. The ore.load or the oml.ds.load functions load R and Python objects from a data store into the user's R or Python current session. The ore.datastore and the oml.ds.dir functions, as well as the all rq data stores and all pyq data stores, views the list of data stores available to the current user. The ore.datastore summary and oml.ds.describe functions, or the all rq data store contents and all pyq data store contents, shows objects in the specified data stores and shows the contents within those data stores. The ore.delete, the oml.ds.delete, or rq drop data store and pyq drop data store functions delete one or more data stores or objects from a data store itself. And here are the list of functions for granting and revoking read access to data stores for database users. The ore.grant and oml.grant, as well as the rqgrant and pyqgrant functions, grant read privilege permissions to other users in the database. The ore.revoke, the oml.revoke, and rqrevoke and pyqrevoke functions revoke read privilege permissions that were granted to another user in the database. So these functions grant and revoke access to users in the database to your data stores. Okay, so now let's go over some quick examples before we jump into the coding notebook demonstrations. So our first example here, we'll build a GLM model on the iris dataset using OML4R and OML4Py. We will then save the resulting models to the respective R and Python data stores named dsr1 and dspy1. So we can now view the contents from the data store that we just saved those models into. We can see that the models are now saved into their respective R and Python data store named dsr1 and dspy1. And we can view those outputs here on the right. The arguments for ore.datastore and oml.ds.dir include a name parameter standing for the name of the data store and the type parameter, which retrieves information about certain data stores. So let's go over the different options for type. The different options for type include pattern or regex match, which returns data stores that match the passed in name pattern. So it'll find data stores that match the pattern of the name input that you have inputted into the function. The user type lists the data stores created by the current user. Private lists data stores where read access cannot be granted by the current user to other users. The all type lists all the data stores the current user has read access to. Grantable lists data stores that the read privilege can be granted by the current session, the current user, to other users. Grant lists the data stores the read privilege has been granted by the current user to other users. And finally, granted lists data stores where the read privilege has been granted by other users to the current session user. The outputted data frame with this information has the columns that show the data store name, the object count in the data store, the size of the data store in bytes, the data store creation date, and the data store description. This is some of the information that we can get by running ore.datastore and oml.ds.dir. So now that we are able to list our data stores, let's look at the contents within those data stores. So we can see that the models are saved into the respective R and Python data stores named dsr1 and dspy1. And we can see that here on the right-hand side of the screen. The arguments for viewing data store contents include passing in the name of the data store and an optional parameter titled owner, which specifies the owner of the data store in order to summarize. The default value is the current user. The outputted information is returned in a data frame, and this data frame includes the object name, the object class, the object size in bytes, the object length, the amount of rows in that object, and the amount of columns in that object. Some common errors that can come up when using these two functions include the name input not being a string or maybe potentially being empty. The owner of the data store is not the current user, and the read privileges have not been granted to the current user in order to see those contents, or simply the data store you are trying to reference does not exist or is misspelled. So here are some examples of how to grant and revoke data store access to a user from R as well as Python. In this example, we can just assume that we are the user OML user, and we will be granting access as shown on the screen to user OML user 2. The first argument will be the name of the data store to grant or revoke access to. The type argument specifies whether the grant access is for either a data store or a script. And here we have it labeled as data store. And lastly, the user argument specifies which user to grant or revoke access to. On the left-hand side, those are the functions that pertain to the grant. And on the right-hand side, those are the functions that pertain to revoke. So now we can just quickly demonstrate how to delete data store objects or a data store entirely. So to delete objects from the data store, we specify the data store name as the first input, and then pass in as a list the objects from that data store to be deleted individually. And that is shown on the screen here. To delete the data store entirely, we will just pass in the name of the data store to be deleted, and that is shown on the right-hand side of the screen. So now we've walked through some quick examples in the presentation. Let's go to the coding environment and walk through some examples and some coding examples there. Okay, great. So this is the Oracle Machine Learning Notebooks environment, and we will be demonstrating the data store and its capabilities in some coding examples here. So first things first, let's create a machine learning model using the in-database machine learning algorithms. We will create a GLM model in both R and Python. We can see some of those model output details here. Next, we will be creating a native R machine learning model, as well as a native Python machine learning model. And we can see those model output details here. We will be saving these models to lm.mod and lm, and then previously we will be saving the in-database models to glm.mod and then glm_mod. Now that those models have been created, let's save those model objects into our data store. So first, we will be running the ore.save, passing in both the in-database model and the native R model. So that would be glm_mod and lm_mod, and then give the data store a name that we want to save it into. And in this case, we'll be using dsr1 and overwrite any existing entries. We will also just create a list of objects and save that list into the same data store. And notice that we have an append equals to true, meaning that we will be appending this list to any existing objects that exist in the data store. The same thing will be happening in Python, where we will be saving both the in-database model and the native Python model into the data store named dspy1 and override any existing entries. We will create a dictionary with objects and then pass in that dictionary in a separate save or oml.ds.save line and also set append to true. So this will have saved the models and the list of objects in both R and Python. So now let's just list the data store that we've just created by running the ore.datastore and passing in the name of the data store. In Python, we will be running the function oml.ds.dir and also pass in the name of the data store. With the outputs, we can see the data store name. We can see the amount of objects in that data store. We can see the size in bytes. We can see the creation date as well as the description. And the same information follows in Python with the data store name, the object count, the size, the date, and the description. Now, in order to view data store contents, we can run the functions ore.datastore summary in R, passing in the data store name. And in Python, we can run the function oml.ds.describe, passing in the data store name. The outputs are as follows. We have the object name inside the data store. We have the class of that object, the size, the length, any rows of that object, and any columns of that object. And here we can see both the in-database model, the list, as well as the standard R model. And as well, the same information follows in the Python interface. With the object name, we have the in-database model, the standard Python model, and the list object that we created, dictionary. And in order to view data store contents using SQL, we can run the function all RQ data store contents in the R for the R interface. So we'll be viewing R data store contents from SQL using this function here and specify the data store name of the contents that we want to view. And we will be specifying DSR1 as the data store that we've been using throughout these examples. To view Python objects that exist in Python data stores from the SQL interface, we can run the function all_pyq data store contents, where the data store name is dspy1 as we've been using throughout our examples as well. And by running that, we can see the objects that exist in the dsr1 and dspy1 data stores. And we can see our model as well as our list in R and our dictionary in Python. And we can see both of our in-database models and standard models. So if we want to load data store objects back into the current session, we can run the function within R, ore.load, and within Python, oml.ds.load. We will specify the name of the data store that we want to load objects from and pass in a list containing the objects that we want to load into our session. Here we'll be loading glm.mod. And in the Python interface, we'll also pass in the data store name as well as the object that we want to pass in. And in this case, it'll be glm_mod. And by running those, we see that those items have been returned back in the console, and those have now been loaded into the current session for use. Yep, and we can represent that that has now been loaded again one more time by just running the summary command and outputting some summary details. So in order to delete data stores and delete data store content, we will start by deleting some data store contents. We'll be running the ore.delete in the R interface, passing in the name of the data store, as well as the objects that we want to delete in a list format. And then in the Python interface, we will be running the oml.ds.delete function, passing in the name of the data store, as well as a list of objects that we want to delete from there as well. And by running these commands, we can see that the console has outputted the name of the object, and we can verify if it has been deleted. So if we run the data store summary again to view the contents in both of those data stores in R and Python, we will see that the GLM mod has been deleted from both of those data store contents. In order to delete the entire data store itself, we will not pass in any objects and simply just pass in the name of the data store to the ore.delete in the R interface and the oml.ds.delete in the Python interface. And by doing that, we will delete the entire data store itself. And now to represent deleting a data store from SQL, we will need to just create one more fresh data set or data store. And we will do that by just running a simple ore.save on the original model into a new data store named dsr2 instead of dsr1. And we will do the same thing for the Python interface with oml.ds.save, saving the original model that was created into dspy2. So now we have created two fresh data stores. We can now represent dropping those new data stores from SQL. We can drop the data store created in R from SQL by using the rq drop data store command and passing in the name of the data store. And we can pass in the Python, we can delete the Python data store using the pyq drop data store command in the SQL interface, passing in the name of the data store that we want to delete. And in both these cases, we're deleting the new data store that we just created. In order to grant and revoke access privileges, we will basically, now that those two data stores are have been deleted, we will create one more data store. We will save our GLM mod that was created earlier into a new data store named dsr_glm mod. And we will do the same thing running oml.ds.save in the Python interface on the model that was created there. And we will save the Python model in the data store named dspy_glm mod. So in order to grant access, we will be running the ore.grant function, passing in the data store that was just created. We will give the type, which will be either a script or a data store. And in this situation, it will be a data store. And the user that we will want to give permission, read privilege permission to, and that will be the OML user. So the same thing here on the Python interface, we will be running oml.grant, passing in the name of the data store we want to grant access to, the type being data store, and the user we want to grant that access to. And that has been granted successfully. And in order to just revoke access to a user, we will be running the ore.revoke in the R interface, passing in the data store again, the type, and then the user that we want to revoke access to. And in the Python interface, we will be running the oml.revoke, passing in the name of the data store, the type, again, being a data store, and the user we want to revoke access to. And that We'll conclude our demonstration of the data store in the Oracle Machine Learning Notebooks environment. So to wrap up, here are some relevant links that you can explore to learn more about the Oracle Machine Learning platform and data stores as well. You can view our homepage and our blog for a range of helpful topics, as well as our GitHub to view currently available coding notebooks. We also encourage you to subscribe to our monthly office hour session and then review our documentation for more information on the data store with additional examples to further aid your development. And with that, I thank you all for your time, and please feel free to send any additional questions you may have about the data store to my email at akash.dharamshi@oracle.com, as well as to send any additional questions to Mark Hornick and Sherry LaMonica. Thank you and have a great rest of the day.
Okay. Thanks, Akash. So we had a few questions that came in. We'll just highlight a few of these here. Are there any alternatives to still use OML4Py when the local Python version is older than the OML4Py Python version? Sherry, you had a response to that. Would you like to comment?
Right. So there's no specific size limit for any object that's saved to the data store. We would expect that if the data store were to grow, very, very large, that there may be some performance implications, but we haven't done any benchmarking at this time.
Next question was, can models' hyperparameters also be stored in the data store as metadata for the model? And, in this case, the information, if you already have the metadata as part of the model, then of course that would be included, but you could save whatever hyperparameters you wanted as a single or multiple Python objects, store those in the data store, and then access those by loading them for subsequent use. So that would be fairly straightforward. We had a request, can we make this notebook available to you? Yeah, we'll post it to the Ask Tom session. So if you go there, you will find a link and you can download it and use it as such. Another question, the max size of the model. I think Sherry's already addressed that there is no explicit limit, but as she said, performance may come into play at that point. And what are the limits of reading, writing models to data stores per second using Python? And can we attach metadata to the models like a JSON or YAML file? And I think that goes back to the previous question as well, that you can store whichever metadata that you would like as objects in the data store along with the model, and then simply know that that object is there and you can use it subsequently. Benchmarking as far as reading, writing models to data store, we have not conducted at this point, but we would certainly be interested in hearing any feedback that you have on what you find there. Where or in which schema is the data store stored? It is in the, it's associated with the user schema. So the space that's taken up is actually there. Sherry, you're adding an answer to that as well. Would you like to say anything more?
I was just about to say the same thing. It's in the user schema and it's grantable. So you can share data store objects among users.
Excellent, thank you. We have one other. Why do we have to request, renew an access token every time we want to interact with the data store? In terms of getting an access token, the access token is only applicable to the REST interface. Sherry, do you want to say anything more on that?
Yeah, there's no need for an access token when interacting with the data store. The access token is for Autonomous Database when you're using our SQL and REST APIs for embedded execution for both R and Python.
All right, I think now we are at the end of our questions. So thanks again, and until next time, have a great week. Take care now.